I am Abeadharan from Yarrow third year. Today we are going to see about applications of material characterization. Material characterization. Characterization has several main aspects. Accurately measuring the physical and chemical properties of materials, providing local microscopy, accurate measuring, determining the structure of materials. A slight history. X-ray were discovered by W.C. Regiment in 1895 and led to serve used. X-ray radiography is used to create image of light. Opaque material refers on the relation between the density of material and absorption of X-ray. Applications include varieties of medical and industrial applications. X-ray, fluorescent spectrometry, relieves an characteristic secondary radiation emits by material when excited by an high energy X-ray source and is used primary to determine the amount of particles elements in materials. X-ray crystallography refers to the dual wave particle nature of X-rays to discover information about the structure of crystalline material. Single molecule diffractions. The scattering of a single electron is weak but not too weak. A crystal amplified the signal by summing up the amplitude of from 10 to the power of 24 electrons. Don't even T1 TH looking at a single electro-significant electro-diffraction plate RN. X-ray diffraction method. Lave orientation single crystal polychromatic beam fixed angle. Rotating crystal lattice constant single crystal monochromatic beam variation angle. Powered lattice parameter polycrystal powered monochromatic beam variable angle. And in the black reference method, title Ellis Plavan RL Bitovic title X-ray source under the crystals. The beam which are refracted in a backward directions are recovered. One side of the cone of lane refraction is defined by the transmitted beam. The film inserted to the cone with the diffraction spotted generally lying on an hyperbola. The lave method is mainly used to determine the orientation of large design crystals while radiation is refracted from a transmission through a fixed crystal. The diffracted beam from arrays of spots that lies on the curves on the films. The Bragg angle is fixed for the even set of planes even set of plants in the crystal. Each set of plants picks up and the diffraction or particulated was edged from the white radiation that satisfies the Bragg law of the wall of Ford and the theta involved. The power method. If a power method specified is used instead of a single crystal, then there is no need to rotate the specimen because there will also be some crystal at an orientation from which diffraction is permitted. Here a monochromatic X-ray beam is inserted on a powered or polyostemline sample. This method is useful for samples that are deflected to obtain the single crystal form. For every set crystal planes, by change one or more crystal will be in the correct orientation or give correct Bragg angle to satisfy the Bragg equation. Every crystal plane is thus capable of diffraction. Each diffraction line is made up of a large number of small scopes, each from a separated crystal. Each spot is so small as to give the arrangements of a continuous line. Here's a small diagram of electron diffraction. The diffraction pattern on the left was made by the beam of X-ray passing through an aluminum foil. The diffraction pattern on the right was made by a beam of electron passing through the same foil. X-ray fluorescence XFR method. Instruments. X-ray fluorescence system utilizing and analyzing crystals. The filtered primary X-ray from the tube hits the sample and produces the fluorescent radiation characterization of the element in the sample. This radiation passes through a colorimetric and the relative wavelength are separated by the diffracting crystals. The intensity of each wavelength is determined and recorded as the synchronized detector rotation in any arc around the analytic crystal. XRF features: Energy Dispensive X-ray Fluorescence Technique (ED-XRF) provides one of the simplest, most accurate, and most economical analytic method for the determination of the chemical components of many type of material. It is non-destructive and reliable, required no or very little sample preparation, and it is suitable for solid, liquid, and powdered sample. It can be used for a wide range of elements, from sodium 11 to uranium 9 to 1, and provides determining limits at the subpump level. It can also measure concentration up to 100% achieve easily and simultaneously. Thank you.